All right, hope lunch was good. Gonna get started again. This is Jason and Greg behind me here. Except it's Joe and Jim. That was supposed to be funny, but it's not nearly as funny when you plan it with the speakers beforehand. And yeah, okay. This is Jim Weirich and Joe O'Brien. They're gonna be talking to us, I guess, about mock dialogue. Yep, conversations on testing and mocking. So it should be really, really good. Still need people for the showdown, so just send me an @ message if you really want to win some free books or training. So, enjoy.
Yeah, hi, I'd like to speak to desktop services. Yeah, okay, I'll hold. Yeah, desktop services. Yeah, I'd like to, my name? Yeah, Joe O'Brien. Yeah, my employee number? Yeah, 43215. Yeah, my location? Building 2, second floor, desk, 3801. Look, is there anything else you need, like maybe the name of my firstborn? Okay, so here's my problem. I tried to log in this morning in the system, and it won't accept my password. Yes, I'm sure I entered it correctly. Yes, I checked the shift locks key. Yeah, I tried that too. You look into it? Okay, yeah, I'll hold.
Hey, morning, Joe. Oh, sorry. I didn't see you were on the phone.
Yeah, no problem. I'm talking to desktop services. I can't seem to get logged in this morning.
Well, system's working for me. I was able to get right in.
Great, then the problem's mine. Yeah, I'm still here. What? My login's been locked out because of too many failed login attempts? Well, that doesn't make sense. I've been typing my password correctly all along. I don't understand what... Oh, yeah, never mind. Okay, yeah, can you unlock that for me?
So,
okay, thanks.
So what'd you do? Fat finger your login again? Log in with the shift lock on, maybe?
Of course not. You know I've remapped shift to control for Emacs. No, the answer's actually more complicated than that.
Go on. I'm all ears.
Well, you know we've been working on the single sign-on initiative, right?
Right. You and I have paired on some of that code.
Right. So yesterday I was working on the code that actually logs us into the network. Mm-hmm. And I've been doing the whole thing test-driven, just like you taught me. I mean, doing the whole thing, all of my tests first. But when it came part to test the part that handles the login failure, I just wrote my test, provided a bad password, the login fails, and in good TDD manner, I'm forced to write the code that handles the failing login.
That's good work. So, what's the problem?
Well, evidently I ran the unit test too many times yesterday and triggered my password locked out.
What? You used your real account and password for the tests?
Well, of course. I mean, you know we don't have a test login system, and I have to test my code against something.
Well, there are alternatives.
Like running with your password?
No. I was thinking more along the lines of using mock objects.
A what object?
A mock object or a stub, or test double if you prefer. There are several names for these things, but the basic idea is that during your test you talk to an object that pretends to be pretends to log on to the system for you. Externally, it acts just like the real object, so you can test against it, but internally, it does something completely different.
Well, that's interesting. You want to pair with me and show me how this thing works?
Sure. Show me what you've got.
Okay, well, let's see. Here's the first part of our code.
Okay. All right, cool. So, this login service object, where does it come from?
Oh, we do it in the initializer, like this.
Ah, okay. So to start up the report printer, you log into the system, and then you get back, looks like some kind of token. What is that?
Well, yeah, a security token. It indicates you successfully logged into the system.
Okay.
I mean, it's just a string that identifies you as a particular user. It's built in timeout, so you can only be given a token for so long before it expires. And yes,
Okay.
it's cryptographically signed, and you can't forge it.
Yeah.
You know, it's one of those private public key things.
Okay. Do you care about the value of the token in your code?
No, not really. I mean, just whether it's nil or not. A nil token means that the login's failed. The token's good, we just pass it back to the login system in later operations.
Okay.
For example, let's see, let me pull this up. So here's the code where we check to see if we have permission to perform a print operation.
Okay, we log in, and you pass in the token there. Okay. You just pass the token back to the service then. We
Right.
never actually use this value.
Exactly.
Okay, well good. This will actually be pretty easy. You have most of the code there already. All we have to do is change the initialization a bit. May I?
Yeah.
Something maybe like this. There.
Wait a minute. So you made the login service a parameter to the initializer. That seems inconvenient.
Well, maybe a bit. But it makes your code less dependent on the login system. See, we move the responsibility for creating the login system out of your code and into someplace else.
I don't like it.
Well, tough. But now your code doesn't depend upon the login service name anymore. It only depends on the fact that there exists some object that responds to that login service protocol. Now we can give your code any object that acts in the same way, and you're good to go. Your code won't care.
Okay, good point. But I just still don't like it.
Okay, fair enough. Just bear with me a little bit, and we'll fix that later. Let's concentrate on the issue at hand for right now.
Okay, fine.
Okay, so now we could write our test like this.
Okay, I think I see where you're going. Now we can write a dummy version of the login system. Here, let me type. It might look something like this.
Yeah. Good. You know what? I like the return of the string fake security token. That's a good idea. Since we really don't care what the value of that token is going to be, we might as well use some kind of string that describes itself. It makes debugging later a little bit easier. That's good.
Debugging? I thought you told me with this TDE stuff we don't need to do debugging.
Well,
Okay, just kidding. So this handles a case where we have a good login, but how do we handle a bad login?
well, there are a couple of ways, okay? One way is to make the login service check the password. If you test with the string password, then it's a good login. If you pass in anything else, then it can return a bad login. Maybe something like this.
Okay, that seems straightforward enough. And I can see adding the logic to allow method to return true or false, depending on what the test needs at the time. Oh, but I can see this logic getting kind of convoluted. I mean, if there's a lot of different scenarios, you have to accommodate for all of them in your fake class.
Yeah, you're right. If you're not careful, your fake objects can become as complex as your real objects, and then you have to start testing your fakes. But that way lies madness.
So you mentioned other ways. For example,
Okay. A simple way of avoiding complex fake objects is to use a specific fake object for each and every test. That fake object only knows what is needed for that given test, and then we just write one for the good test and we write one for the failing test. Maybe something like this, if I may. There we go. Okay. We just return nil right off the bat, and then our test could just simply be something that looks like this.
okay, cool. But you didn't write the allow method for this fake.
Right. Since our test isn't calling allow, the fake object doesn't need to provide it. It's just customized specifically for this test.
That's pretty cool. I like this. Well, I think.
Your brow is furrowed. What's
Well,
the problem?
I really do like this and all, but it seems like I'm going to end up writing a lot of fake classes and for a lot of different scenarios in my class. I mean,
Right.
I wish there was an easier way.
What if you could customize your fake objects on the fly?
Customize behavior?
Yeah.
I don't get it.
Okay, let's talk in code. How about this for a fake class?
Let's see. That block login behavior. Okay, that's a block you're passing in. You give it a block when you create it?
Yeah. Just pass in the behavior in the block, and that means your good login test now just looks like this. Okay? The block specifies return a fake security token string, okay?
Okay.
Then our bad login test simply looks like this. One fake login service handles both logics. The fake is now logic free. The good login returns a token. The bad login returns nil. And the best of all, you specify the behavior you need right there in the test, so it's immediately clear what you're doing.
Okay, I gotcha. You know, I think I can get used to this. And we can do the same thing with allow, right?
Mm-hmm. Sure.
But, okay, now we need to specify a block for the allows method behavior. That might be 2 methods. You know, I can see this really getting out of hand for fakes with a number of methods.
Yeah. You're right.
You know, I'm almost tempted to write a little DSL to specify the little behaviors like this and make it easier.
Yeah, I know you like DSLs.
Yeah, I mean, this would be great. We could... You're grinning. What do you know that I don't?
Well, actually, you might want to check out some libraries on RubyForge.
You mean somebody's done this already? You know, I was really ready to go off on a wild goose chase and inject some reality here. Okay, so what are you talking about?
What you need is a good mocking library. Now, there are several available. I like to use FlexMock.
Well, why that one? How do you know it's the best one available?
Just a hunch.
So, aren't we using mocks already?
Well, technically we're using stubs, but, you know, terminology aside, a good mock library will provide both mocks and stubs for you, all within its framework. So it's perfect for what we're trying to do here.
Okay, well, why don't you show me?
Okay, let's go back to our good login test. Okay. Now, instead of creating a fake login service, we're going to create a mock instead. Okay? Then we just tell the mock what it needs to expect.
Interesting. So if I'm reading this correctly, I'm creating an object on the fly and then telling it what to expect. This is just like our last solution, except I don't really have to write the actual fake service class.
Sure, the mock serves as the fake service class for you. And not only that, the mock can do a lot more for us. Now, tell me what would happen if the login is never called in your code that you're testing.
Well, I don't know about FlexMock, but in the original code, I mean, we would just ignore it.
Right, it'd just be ignored and nothing would happen. Right, so this is true with our test right now as it's written. However, with a very simple change, we can do this. And all we do is add that once call to the mock, and that now tells FlexMock to complain really loudly if that login call is never actually called.
What? Complain loudly if something's not being called?
Yeah, FlexMock installs a teardown method that checks for all the mocks after every test run. If something is not called that should have been called, FlexMock will complain at that point.
Okay, so let me get this straight. I'm not only creating an object on the fly, but then I'm also setting up expectations that'll fail if they're not met during the test.
Exactly.
Okay, well, let me ask you this. In
Okay.
the old setup, I was able to test this, but I'm wondering if, I actually wasn't able to test this, but I'm wondering if maybe mocks can help us out here.
Okay.
I want to verify that the username and password that I pass into the start command are the same username and password that we give to the login method.
Oh.
Can we try that?
Oh, sure. That's quite easy to do. Look, we just tell the mock what parameters to expect. The with method on the mock works quite nicely for this.
Okay, so you're saying something like this?
Yeah, except we don't need to keep using your real password anymore. How about something like this? There.
That's really cool. I love the way you just tack on more options as you need them.
Right, exactly. We call that a fluent interface.
Okay, so what else can a mock do? I mean, can it handle things like throwing exceptions and so I can test the exception handling logic?
Sure. You can throw exceptions. You can specify ranges for the numbers of times that it might be called, like never called, called once, called twice, called 100 times. You can specify the logic that is to be executed when a method is called on a mock in the form of a block. You can do just about anything you can think of in the mock, actually.
These are pretty sweet. So why didn't you tell me about them from the beginning?
Well, a lot of people think that mocks are kind of magical, and they should only be used by, really advanced programmers. And I just wanted you to realize that the mocks we're writing are just a simple extension of those fake objects. It's a simple, basic test technique that everybody should be using. It's much like the fundamentals of arithmetic.
Ah, you mean like ambition, distraction, uglification, and derision?
Right. Hey, what you doing?
Well, I'm having so many problems solving this last layer. I mean, I can get the first two, but it's this last one that's just absolutely killing me.
Oh, that's really quite simple. You just need to apply the principles of wave mechanics, wave operators from quantum mechanics to help with the bottom layer. It really helps.
Never mind.
So let me ask this in a different way. Why are you trying to solve the Rubik's Cube?
Oh, I'm running my unit test.
Taking a while, huh?
Well, just a bit. I mean, we got a really large code base now, and it's really well covered by tests. I mean, it's
Right.
not really a surprise that it takes a while to run.
Well, what's a while?
About 30 minutes.
That's kind of a large a while. Have you ever seen Jeff Nielsen's thoughts on the psychology of build times?
No, sounds interesting. Fill me in.
Well, he did some research of the effect of build times and how they affect developers. And he discovered that for unit tests, there's an interesting psychological effect that takes place when your tests start taking more than 10 to 30 seconds.
Yeah, okay.
Yeah, the number of times the unit tests were run actually dropped dramatically when the test took more than 30 seconds.
Come on. I mean, how in the world can you expect these tests to get down to 30 seconds? We're talking about a substantial suite of tests here involving controllers, models, services, databases, interactions. I mean, they're all trying to...
Well, those really aren't unit tests, Michael Feathers says that in order for something to be a unit test, it must follow about 5 basic things. Number 1, it's not supposed to talk to the database. 2, it should not communicate across the network. 3, it should not touch a file system. 4, you should be able to run it at any time, even if other people are running unit tests. And 5, you shouldn't have to do anything special to get it up and running. You should just be able to fire it off and forget it.
Okay. Well, I'll give you the not communicate across the network and can't run at the same time, and yeah, maybe even the not have to do special things, but how in the world am I supposed to not touch the database or the file system? I mean, this is a Rails application. We're talking MVC, database, app, fixtures, migration. Everything hits the database.
Well, certainly some kinds of tests are going to hit the database, and that's fine. But we can certainly minimize the number of hits on the database in many of our tests.
Okay, well, if you've got an idea, I'm willing to listen.
Okay, show me one of your controller tests.
Okay, well, I'll just pull this one up. It's a pretty straightforward one.
Okay. So, what are you testing here?
Well, I think it's obvious. I mean, I'm making sure that the contact variable is assigned and that it contains all the contacts.
Okay, yeah, that's what you're testing here, but what behavior are you looking for?
I'm not sure I follow.
Okay. The job of a controller in MVC is orchestration, right?
Yeah. Yeah, I mean, in this case, it's getting information from the model and then making sure it's in the form that the view needs.
Okay, so let's test that behavior right here instead of making sure that the ending state is what we expect. Let's break down again what we're trying to test. First, we want to make sure that the controller asks for all the contacts. Second, we want to make sure that those contacts get assigned to the instance variable for the view to use it. And then thirdly, we want to make sure that it returns a successful return code.
Okay. But how do we go about not hitting the database?
Well, how do you think? Mocks, of course. Let's change the test to this.
I like that. Well, kind of.
Kind of. Doesn't sound convincing.
Well, okay, I'm looking at this. Aren't you testing the implementation here? I mean, you're specifying exactly what's happening on the inside of your method.
Yeah. But don't be fooled into thinking that your first test was entirely black box either. In the end, what you're doing is grabbing all the contacts out of the database to match against your list. In this case, we're making sure that all the contacts are retrieved. The contacts that are retrieved are the ones that are set to the instance variable.
Oh, okay, now I see it. So you're using a symbol, which actually could be any object, and then checking that the controller sets that into the appropriate instance variable so that the view's ready for it.
Right, exactly. Now, from what I can see, we've eliminated at least 2 database calls with just that one test. If we change all the tests to use this, we can eliminate the last database hit as well.
The last hit? We're not hitting it anymore.
Well, actually, with each step, we reload the fixtures into the database to give us a fresh start. So we're really hitting it again.
Wow, I never really thought about it. I mean, those can really add up over time.
Sure.
Okay, that's fine for that one, but what about a more complicated one, like this one for update?
Okay, let's look at this. What are we doing here?
Well, we're doing quite a bit here. First, we're getting an existing contact. Then we're taking it and we're...
Okay, let me rephrase. I'm not asking what is happening, I'm asking what behavior we're looking for. What are we trying to test?
Well, the controller should get the updates that are passed to it, and if it's able to successfully save the model, then it should redirect to the correct URL and update the flash message.
Okay, so let's just do exactly that. This time we're going to create a mock object and then manipulate that mock object. So instead of having something like this, where you grab a fixture, we'll have something that looks like this, where you create a mock object.
I haven't seen that symbol model used in FlexMock before. What is that?
Well, FlexMock, when it's used with Rails, knows about Rails model objects. And you're just telling FlexMock, hey, that this mock you're going to create is going to mimic the behavior of the contact active record model. It's going to automatically mock out a few methods for you, like ID, it'll report its class as being the model class, things like that. It makes it a little easier to use mocks with Rails.
Interesting. So is that all we need to do then?
Well, we have to tell the mock what it needs to expect during its lifetime. Probably something like this.
Right. So we update the attributes on the object, and then we save the object. That's what the controller will be doing.
Right, exactly.
But I don't get the contact attribute thing. What's going on here?
Okay. We really don't care in this test exactly which attribute we're updating, okay? We just need to ensure that the controller passes whatever parameter list comes into the model to be updated, okay? Remember, it's the controller's job to orchestrate, to coordinate. We just need to make sure that the proper things get to the proper places. The controller itself doesn't care about the actual gory details of what's passed to the model.
Okay, I see that. But how do we get the controller to use this mock?
Oh, that's easy too. We just mock out the finder on contact to receive find and just to return the contact.
That's pretty cool. So are we done then?
Not quite. We need to pass that contract attribute symbol into the post call so that it gets passed along to the controller in the first place.
Cool, I'm impressed. So the whole test looks something like this. You know, I find it interesting that we no longer explicitly check that the model's been updated.
Right, exactly. We're not actually testing the model, we're testing the controller. We're not testing that Rails really updates the model when we call update attributes. That's Rails' job to do that. All we're testing is that the controller gives the right data to Rails to perform the operation.
Okay, well let's see if this works. Cool, green bar.
Excellent.
So we can use mocks for more than just mocking out external services, then.
Oh, absolutely. Mocks are great for isolating your tests and allowing your tests to concentrate on verifying exactly what you want to deal with at that given moment.
Cool. It looks pretty straightforward to isolate the controller from the database, but what about models? I mean, I'm assuming that it's okay for them to hit the database because they are intimately connected to the schema.
Well, yes and no, I would say. You'd be surprised at the amount of model business logic that has nothing to do with saving or restoring from the database. Most of that logic can certainly be tested without any database interaction at all.
Okay, I'll buy that. But what about finders?
Well, now see, you're right. Finders are almost always tested against the database, and it makes sense because you want to ensure that whatever SQL magic goes on behind the scenes really pulls back the data that you want, and you're getting the correct results from the database. I find that finders are the great divide between database testing on one hand and just plain object testing on the other hand. You test your finders against the database, and then you mock out your finders for the rest of your code so they never hit the database.
Huh, that's interesting. It makes sense. So it's almost lunchtime. You hungry?
Oh, absolutely. I hear they are serving beautiful soup in the cafeteria.
Okay. What? Wait a minute. What the? What? You got a second? I'm having a hell of a time with these mocks.
I can tell.
So, you convinced me that the mocks are really cool, and I'm trying. But I keep running into problems when I'm actually trying to use them.
Okay. Well, they're certainly not the answer to everything. What seems to be your problem now?
Well, so look, I'm looking at the code to calculate the shipping cost of a package between two stations.
Okay, say that 3 times fast.
No. It seems like a lot of trouble to set up the mocks in this
Okay,
instance.
why don't you just show me the code? Okay, just give me a minute here to kind of look this over. Okay, create a couple of those, and zip code something, address something, customer mock, package mock. Okay, this is really interesting code.
Yeah, it sure is. What are you thinking?
I'm thinking there's something missing here.
Like
Any real code? It's all mocks. Exactly what are you trying to test?
Well, I want to make sure that the station object can calculate the cost to ship a package.
Okay, so the business logic of calculating shipping costs belongs to station objects.
Well, sure. Station 1 might be a warehouse holding a package for a customer. Our client will ship the package from Station 1, the warehouse, to a station closest to the customer. The receiving station is chosen according to the zip code of the customer.
Sure, okay. I guess that makes sense. Now, we can work with that. So the objective of this test is to see if the cost calculations in the station are correct.
Exactly.
Okay, so where are the station objects?
Well, they're right. Oh, crap.
Yeah, you've gone just a little wild with the mocks, I would say. You don't really have any real domain objects in this test at all. Okay, so sometimes one gets so caught up in the process of creating mocks that you lose sight of your testing. I've seen a lot of tests that verify nothing more than that you've created the mocks correctly. So,
Okay, so does this look better then?
okay, create a couple station mocks at the beginning. Okay, that's better. Now we have something at least that's real to test. Let's look at the rest of the test code. Okay. I know, there's still a lot of mocks in there. Do you really care if the zip code method is called?
Well, certainly. I mean, we need to call zip code to find, get the zip code, right?
Well, okay. All I'm saying is that you have a once specification on the mock call to the, and that means that that call must be called at least once to pass this test. Seems to me that whether zip code is called or not is kind of incidental to the problem we're solving.
Okay, I think.
Okay, let me put it another way. If zip code is called twice, would you care?
No.
Okay. And if it was called 3 times,
No.
or 10 times, or 0 times. So as long as you get the right answer, right?
Yeah.
Okay.
Yeah, I'll buy that.
So what you have is a call that is over-specified. We can leave off the once, off the mock, and it will still work. It just won't insist that that method must be called for the test to pass. By the way, that's the essential difference between a mock and a stub.
So we just leave off the once on the zip code call.
Yeah, and probably most of the other mock calls as well. Okay, that's a little better. Oh, and by the way, there's a shortcut you can use that if you have a method with no arguments, it just returns a value. There's a quick little shortcut you can use to specify that. It kind of makes the code a little more concise. Let's use that and see if it cleans it up a bit. Okay. Code's getting a bit cleaner. I'm still bothered by something else. Seems like we're using a lot of mock objects. And what are they being used for?
Well, we need them to calculate the shipping cost.
Okay, really? What's the shipping cost based on?
The distance between 2 stations.
And just that.
Yep.
Okay, so why do we need to know about the customer in this test?
What's the customer object that has the address?
The address of the receiving station?
No, the address of the customer.
So you're shipping direct to the customer?
No, to the station closest to the customer. The customer will pick it up from the local distributor.
So bring up the cost to send function. I want to see something. Yeah. Just as I suspected. You have a train wreck.
No, it's unlikely we ship by truck.
No, I mean the code is a train wreck.
Excuse me?
See how those methods are all joined together by the dots? It's like a line of train cars just ready to get derailed. Hence the term train wreck. Take a look at that first line of code in that method. What do you see?
I see it getting the receiving station.
By
Asking the package for the customer.
and
Then asking the customer for the address.
and
Okay. And then getting the zip code from the address and then finding the assigned receiving station for that zip code area.
right. And that's the train wreck. We're exposing a whole lot of data structure to the simple calculate cost function. If we ever refactored the schema, we'd have to go in here and change this function. It's like allowing a customer to have multiple addresses. Excuse me. If we change the schema, like allowing the customer to have multiple addresses, this code would be unnecessarily affected.
Okay, well that makes sense, but how do we fix this? I mean, we have to get the zip code.
Okay. Yeah, but it shouldn't be the responsibility of this code to do that. There's a number of ways to fix this. We could drop the method and make everybody call cost to send and then pass in the station directly.
But that would make all the callers have to know about the data structure. It sounds like we're just making the problem worse, really.
Okay. Or we could give the package the responsibility of knowing its receiving station.
That's interesting. So then the cost to send would look something like this.
Yeah. Exactly. And now, look what it does to our tests. Most of the mocks are now gone. We only need to mock out the receiving station method on a package. The details of exactly how the receiving station, how to get the receiving station is no longer exposed. At least not in the test of our code.
Right, but that navigation code still needs to be somewhere.
Sure, but it's no longer part of our cost calculation code. By putting it in the package object, it's in one location, and changing it in the future will be much easier.
Okay, but the train wreck code still exists. It's just on the package object, just one train car shorter.
It's one train car shorter, but yeah, we should probably really look at that code too and consider if we need to refactor it any further. At the end, it's just a matter of balancing the number of public methods in an object against its responsibilities and the need to keep the code dry. It becomes a balancing act.
And the ease of testing.
Right.
So you notice this problem because the number of mocks that we needed in our test.
Right. When the test became ugly, it's a good clue to us that the code that's being tested is ugly. We need to become sensitive to that ugliness in our code and test and be ruthless about removing it.
Ban the ugly. Now there's a slogan I can get behind.
Yeah.
So, are we done here then?
Well, we still need to rewrite the receiving station method in the package class.
Yikes, we call that method here, but since it's mocked, it might actually never get called.
Yeah, truthfully. And that's sometimes the problems with mocks. You don't get that inter-object testing done so well. And truthfully, it's easy if it's easy to create a package object without hitting the database and without creating a whole network of objects behind it. You might as well just use a real package object in the test rather than a mock, and that would solve some of that problem. No needs for mocks in that case.
Okay, well that makes sense. So, what do you think? Time to call it a day?
Sounds good to me. I need to get home and catch the showing of the trial of the century. What you heard was just kind of a dialogue of some ideas that we have about testing and mocking. And we're going to open it up for questions at this time. Yes, David.
I, like you, Jim, I also like FlexMock a lot. I do, but one thing I was wondering, I always want in these mock things for there to be, I guess, a can, like object can receive, which in FlexMock is really should receive without a quantifier. But I really want it to be can receive. I mean, it's just my
Alias method.
sorry.
Is it alias method?
Actually,
Yeah, well, I mean,
this is an ongoing debate, and the big difference between stubs and mocks are really the difference between can and must. Okay? Because stubs, the little definition here, that fake objects that you use in testing, there's lots of terminology behind that. The terms we use a lot, you hear a lot, are stubs and mocks. Stubs are kind of fake objects that you can call into and give you data back, but that's all they do. They just kind of stub off the call and provide fake data back. A mock object is a little more active than that. It actually verifies that how you call it is done in the right manner. It's called the right number of times with the right number of arguments and things like that. So that's kind of the difference between a mock and a stub. Some mocking libraries, and this is a philosophical difference between FlexMock and Mocha, which a lot of people use. And Mocha is a great library as well. If you prefer that, that's fine. Mocha says you create a stub or you create a mock, and kind of has this mental division between them. In FlexMock, we don't have that hard division between the mocks and stubs. We create, when you get a FlexMock, a raw FlexMock with nothing on it, is open and loose. You can call it, you don't have to call it, you can call it any number of times. And then everything you add on to that end, you know, the with specifications, the and return specifications, the once or twice specifications, tightens up the constraints and brings the constraints in tighter and tighter. So it's kind of the philosophical thing, is that I really don't want to have that hard divide line between mocks and stubs.
right, but still, since you have should without a quantifier, essentially is what we would say. I think in English we would, or would be equivalent to saying it can,
But
meaning it,
Yes,
it doesn't
yeah.
have to, but it can. So.
and I could change to can, but then if I added like a one specifier, then it reads wrong for that as well.
All right, no, then, well, unless you want it, I don't know if this ever happens, but if you want to say it can only receive it,
Yeah,
up
but
to
then,
3 times.
then we have different words for mocks and stubs, and it's whether I want the English phrasing of that to be perfect English, or whether I want the mental model used to build the mock-up gradually to be a clean model. I kind of went for the clean model idea. Some people prefer the clear English, proper English form. And that's kind of a preference.
This is actually the place, because I started using FlexMock because I was pairing with Jim. And I dare not say require Mocha if I'm sitting next to him. But it was weird because I actually fell in love with the library after I started using it. And I think the idea of should, so I agree that the English, there's a semantic problem that we have, but I like the idea of just tacking on once because I think it inspires a lot more of the whole, let's use the buzzword, agile development, right? Because it really lets me iterate in a much more granular level. When I'm using Mocha or something like that, I have to make the decision up front. Do I need to stub this? Do I need to mock this? Whereas with FlexMock, I just start at the base. We saw Stu Halloway at eRubyCon last year. He actually sat up there and just started using symbols until he was forced to use more, and just would keep going, using the most basic thing he possibly could. And FlexMock really gives you that ability as you tack it on. So.
Sorry, just one more comment, and I'll shut up. But I guess the word "should" just is sort of, it means it's mandated. I mean, that's my stumbling block with that. That we don't like. If I say, you should do this. I don't say you should do this once. And I understand that the English to FlexMock or to any, API is, you don't want to kind of stretch the point. But I think that was my problem with it, that should without a quantifier. It kind of took me by surprise a little bit that didn't mean.
Especially since other frameworks use
They
that
default
should
to one,
and
yeah.
do require
Right.
at least one. So that's probably, if you switch from Mocha to FlexMock, that's going to be your first stumbling block that you hit.
Yehuda?
So I have a solution. I have two things. One of them is I think I have a solution. I think it's a
Oh, yeah?
You can say can receive and then only once. So if you say this thing can receive through only once, that actually reads correctly, but can receive it not only once, it reads correctly. So I have a question. I think you guys punted on the doesn't this couple too much to internal looping? I think you had a case where it was already pretty coupled, so it's pretty easy to punt. But in real life, that's considered.
And that's always the problem with using mocks, is that you're kind of looking underneath it, and it's no longer black box testing, it's white box testing.
There's a pendulum swing from it. I mean, when you start using mocks, you're at a point where you're not looking at the internals at all. And you're obviously going to swing way past that, and you're going to hang yourself because you're going to get way too much in the internals. And I found myself writing a custom finder, writing a receiver that's saying find is going to receive all with these conditions, and just, it's a useless test. So you're going to find that natural progression. There's also a couple other areas we stumbled upon, like the fact where you can put up way too many mocks and all of a sudden you're not testing any real code. And we kind of glanced on a couple of things on the surface just to show those things can happen and to think about them, but it's way more than we can cover in an hour here.
But you're right, we absolutely punted on that.
But thanks for showing me.
I find it more mocks you use, but less useful for tests we did in progression.
Yes, and that's why unit testing by itself, if you depend on mocks a lot, you really need to supplement that with tests that go the entire way through. Some kind of functional testing of some type, something that tests the system rather than a unit test. And that's why I like to keep unit tests, and system tests. Yeah, but yeah, don't think just because you have unit tests, that's it. Good point.
Thought I saw a hand. Or somebody stretching. Any other questions? Tomatoes? Throw anything?
Okay.
We're in the South. Is it green tomatoes that you throw? Fried. Ew.
Okay. Well,
All
thank
right,
you very
thanks.
much.